Okay, welcome everyone. Thank you for joining us today, Minitab web demo. So topic today is capability analysis. I'm Nur Sulawati. I'm the technical support at Busy System. Okay, Busy System is an independent local representation for Minitab product and training in Malaysia and Singapore. Before we get started, I have some housekeeping items. This one is the webcast, so maybe you have audio delay. If you cannot clearly by speaker, you will be able to dial toll-free number for Malaysia 1-800-807-043, for Singapore 8001-011-441. Okay, the second one, if you have a question during presentation, please type them into the question box in your control panel. And you may send any time during presentation, but I will address them during Q&A session at the end of today's session. Okay, so I will turn to listen mode only because this one is for recording. So for your information, this web demo will be recorded and you will be accessed back at our website at www.busy.com. Minitab was developed in 1972. Minitab is a software package for statistical analysis, and Minitab are leading statistical software for quality improvement and statistics. Minitab are powerful statistical software. Everyone can use, whether you are statistician or non-statistician. Minitab offer a complete statistical software, and then Minitab also have a guideline that leads you to the answer. Okay, this one is some organization using Minitab in Malaysia, like Western Digital, Toshiba, Nestle, and then in services like banking, CIB. Okay, so this one is Minitab18. Minitab18 is a smart data import. Once you import your data from the Excel, Minitab will remove extra space and make column length equal. And then Minitab18 also seamless data manipulation, which is if you can have a subset, the most frequent value in your worksheet, not only for analysis. You can get some description of the data from the worksheet. And then Minitab18 also automatic graph updating. Once you update your data in your worksheet, you can update graph automatically. And then Minitab18 is effortless presentation, which is if you can import your output graph or output session to the others file like presentation, PowerPoint, and works too easy for you do the presentation and the report. Okay, all the statistic units like statistic, BCC statistic, your hypertesting, your confidence interval, and normality test. For Minitab also provide to cover the relationship between variables, which is if you can find out by regression and ANOVA. And then Minitab also have a quality tools like today's session is we want to know about the capability, and then we have also for measurement system analysis. Okay, and then we have a great sampling plan, and also we have a design of experiment. You can do the optimization by using factor design, or maybe you want to do the Taguchi method. Minitab also have a control chart, which is if you can monitor your process. Okay. To reliability and survival, you can have also determine the product lifetime warranty analysis. So all these statistics are in one package in Minitab. Okay, so today this one is the tools in the Minitab. We mapping with the DMAIC or improvement framework. Like during the define and measurement, maybe we can using Pareto chart to find out the most important factor. And then you can go for control chart, also for capability, and also for graphic, and do the gauge and R. Okay, for the analyze stage, maybe you can using hypothesis testing, ANOVA, your correlation. For the improvement, maybe you want to do the DOE, design of experiment. And then for the control stage, maybe using control chart, capability, and then reliability. Okay, so for agenda today, we have basic plus the we have a capability analysis. We have a normal process capability. We also for non-normal data for the process capability, and then we cover for assisted binning for capability analysis. But for maybe 10 minutes or 15 minutes, we cover for theory first before we go for Minitab function. Okay. So what is a capability analysis? Capability analysis actually, if you want to evaluate how well your process meets a set of requirements that is defined by specification limit, which is defined by lower specification limit and upper specification limit. Okay, when your process is centered in your target and well within in this spec between lower and upper, is more capable of consistently produce product that meets customer expectation. So which is if your process in specification, whether in lower and upper limit, and then your data spread only on your center or in your target. So we consider that the process have capable, but in further we can have like CP, CPK, we have PPPK or others index for capability analysis. Okay, so why we using capability analysis? To ensure that the process meets your customer specification, and then to estimate the proportion of the product does not meet the specification. And then basically this one is example, the objective question to do the capability analysis. Let's say you want which vendor consistently provide superior quality parts, and if the variability in the process is low enough to consistently provide parts. That fall within specification limit. Thus, the process needs to be shifted to operate more effectively within the specification limit. So before we go further, we need to know what is a control limit, what is the specification limit. Okay, so for the specification limit, we have defined by your customer, voice of a customer, and then for control limit, we calculate the limit from the process is from VOP, and then for the control limit is we call it what the process is doing, and then for the specification limit, what we want the process to do. And then same for the control limit, we have upper and lower control limit. Also for the specification limit, we have upper and the lower specification limit. So in this graphical, we have here is a lower specification limit. We have a mean or target, and then this one is your upper specification limit is from the your customer, and then this one is from your process. We have a lower control limit, and here is we have a upper control limit. So before we go further, do the capability analysis, we need have fulfill two assumptions, okay, to get the reliable CP and CPK value. Okay, the first one is the process is stable over time. And then the second one is the normal distribution is adequate fit to the data. So which is for the second part, whether you have a normal distribution or other distribution like Weibull or exponential, so you can do for capability analysis. But most of researcher or practitioner, we want the capability analysis with the normal distribution because we want get the reliable CP and CPK. So process is stable over the time, can measure by the control chart, or stable means that in control, a process in which of the key process responses and product properties show no sign of a special causes. As we know in the variation, we have two types of variation. We have common and the special causes. For the control chart, we want to tackle or detect for the special causes. And then for the unstable, has a both variation, which is common and special causes. And then for the control, process control, we can measure by the control chart. So if we have different control chart, if we have different subgroup size, which is if let's say you have a subgroup size U1, so your control chart should be IMR chart. If your subgroup size U2 T8, so your control chart is X bar R chart. If more than 9, your subgroup is we using X bar S chart. Okay. So this one is your control chart. We can produce this control chart using Minitab also. And then the second part is we need to know what is your distribution. Okay, so to check in distribution, normal distribution, maybe we using histogram, or we have using PP plot or normal T probability plot, and then we using the Darling hypothesis testing for the normal. For example, data is from a normal distributed population, and H1 is a data are not normal distribution population. So which is from Minitab, we can provide, we call it normality test. After this, I will show how to do this two assumptions. The first one is your control chart, and then the second one is normal distribution. Okay, so basically this one, and then this step is need to fulfill first before you get for capability analysis to get the reliable CP and CPK. So this one is step to do the capability analysis. Okay, we start with the collect data. Okay, you can collect data. Okay, so but for information, if you want to collect data, you need to have a subgroup, which is you collect under the same input and condition, which is the same manpower, same equipment, same supplier or environment, because we want to tackle the common and the special variation. And then you enter the data in through Minitab, and then no need to do sort the data. And then after that, you can create the subgroup size using the calculator menu. After that, we show it out. And then from here, after you get collect the data, you can do the assumption. The first assumption, you can verify the stability. So based on the control chart, which is you go for stat, and then you choose control chart. Different subgroup size, we have different control chart. And then the second assumption is you need to identify the shape of distribution. You go for normality test. If your data is normal, so you proceed with the process capability. If your data is not normal, So you need to find the distribution. After that, we have another way, alternative way. We can do transformation during using capability analysis, and then you go for process capability. So if you facing with the normal data, so easy, just collect and then fulfill assumption, you can get the process capability. But if your data is not normal, you need to identify your distribution first, and then after that you can get the process capability, or either you need to do transformation to be normal, and then you get for process capability. So never mind this step, I will show after this how running this step using Minitab. Okay, so this one is the capability index, or sometimes we call it, that one is capability matrices, and then quite popular. And for information, from the Minitab survey, based on the survey from the Minitab, most of the customer, 95% respondent using CP and CPK in order to measure their capability process. So which is they using CP and CPK, which is potential or within capability, and then using the process performance or overall capability. And then others index like sigma level, maybe quite popular also PPM, part per million. And then we have DPU, DPO, and DPMO. Basically, for the capability index, different because we have different type of the data. Okay, so we go so for this webinar, we focus for this kind of the index, which is CP, CPK, and then PP, PPK. So as we know, CP is a potential capability associated with the within subgroup standard deviation. And then for the capability index, we have also CP, we have CPU, which is CP for upper, and then CP for the lower, and then the last one we have CPK. So this one is terms of role, or based on the AIAG standard. So if let's say you calculate the CP or CPK value, 1, we consider the marginal capable. Okay, if your CP or CPKU 1.23 is capable, if your CP or CPKU more than 2 is highly capable. If let's say CP or CPKU less than 1, we consider that not capable. Maybe you need to do some process improvement. Let's say you will need to reduce your variation, or you need to move your shifting to the center. Okay, this one is like, let's say if your CP equal to CPK, so the graphical for your process is center, and then between the specification limit. If your CP not equal to CPK, maybe your process is shift to the right or shift to the left. Okay, same go for the process capability, overall capability, we call it is PP. Okay, PP we also have the same. We have PP, we have PPU, which is upper, and then we have PP is a lower, and also we have a minimum between upper and lower. We call it PPK. So based on AIAG also, we have the same terms of role. Is let's say less than 1 is not capable. Okay, if 1 is marginally capable, if let's say your PP or PPK is 1.23 is capable, is let's say PP or PPKU more than 1 is highly capable. So same if PP almost equal to PPK, means that your process in center and between specification limit. Okay, if PP not equal to PPK, process is not centered. Okay, so this one is the versus is a CP versus PP. Okay, so almost of the capability for the CP is more for short-term capable, and then for the PP is long-term capable, and then for the CP is only calculate for the normal data, and then for PP is for normal and non-normal data. Okay. So this one is the basic method capability using Minitab. So Minitab offer, we have two type of capability. The first one is we call it capability Sixpack, which is if you can handle with the normal data or non-normal data, or you can have a between or within data. And then for the capability analysis, you need to consider other criteria, which is if your data is continuous, let's say your measurement, like your length or your weight, so you have a normal, non-normal data, and then you also have a multiple variables, and they also have between and within. Okay, for the attribute, we have a binomial, and then we have Poisson. Okay. So this one is differences between capability Sixpack and capability analysis. Okay, so for the capability Sixpack, actually Minitab offer and then provide you directly the assumption, which is can appear here is your normality test and then your process control. For the capability analysis, they provide only for capability analysis, no have assumption for normality or for control type. Okay, so so this one is we have a normal data. Okay, so this one example. An engineer manufacturer use a fogging process to make piston ring. The quality engineer wants to assess the process capability. Okay, they collect 25 subgroup of 5 piston ring and measure the diameter. The specification for piston ring diameter are 27 mm plus minus 0.05 mm. So data we using is piston ring diameter. So we go back to Minitab. Okay. Sorry, because we need to further for theory part before we go for hands-on part. Okay. So for piston. Okay. So once you open the data set, okay, which is piston ring diameter, okay, so which is we have 125 measurement. We have 5 subgroup. So the first criteria, which is we need to have a subgroup. So how to run or how to create subgroup using Minitab? If you doesn't have a subgroup, so no need to key in one by one. So you go for calculate, make pattern data. Okay, you choose simple set of numbers. Okay, so I will go to calculate, go to make pattern data, simple set of numbers, and then you need to store where is you want to store. So for example, here I choose C2. Okay, from the first value, okay, value 1, okay, so the last value is 25 subgroup, step value is 1, and then from here is 5. Okay, so this one is the step how to create the subgroup using the Minitab. So click OK. So I will go to calculate, go to make pattern data, choose the simple set of the number. So you choose where you want to store. The first is 1 and then the last value 25, the step group of 1. Okay, so here is 5. So let's say your subgroup is 8, so you choose here 8 and then click OK. So here is we have a subgroup. Okay. So as we know, we need to check in the assumption first before go for capability analysis. The first assumption is control. Is it process is control or not? So go to stat, go to control chart. So choose the variables subgroup and then choose the X bar chart. Because subgroup size we have 5, so we choose X bar chart. So for example, here is the odometer, subgroup size is subgroup size, and then you click OK. So now we already have a process. Is it process control or not? So based on this control chart, X bar and R chart, so doesn't have any sample outside from the control limit, so the process is stable. Okay, so we need go for a second assumption, which is we need to know the normality of your distribution. How? Go to stat, go to basic statistic. Okay, choose the normality test. So here is your variables diameter. So you choose AD. Maybe most of the fraction of process improvement we're using AD. So click OK. So based on this PP plot, based on the P value is more than 0.05, then we consider that this process is normal distribute. So now from here we know we process is control, and then the process is normal distribute. So we can further, for our objective is find the capability, which is go to stat. Okay, go to quality tools. Okay, you choose whether capability analysis or capability Sixpack, because we already do for the assumption. So you choose capability analysis is a normal. Choose the normal. So okay, sorry, we do go to stat, go to quality tools, choose capability analysis, choose normal. Okay, so from here is the diameter. From subgroup is whether you typing again or you can insert here, and then your lowest spec is 73.95, and then for the upper spec is 74.05, and then your historical mean 74. So in default one, whether you have a lower or you have a upper, so you can calculate the CP, but we doesn't have a CPK. Okay, so if you include all this information, so you can get all the information. Okay, so based on what you have done. Okay, click OK. Okay, so I will do again. Go to stat, go to quality tools, choose analysis, and then choose normal. So you choose include all this one and then click OK. So you get this kind of the capability. So the first thing, you get this graph. Okay, maybe you go for the CP. So CP here is 1.66, which is greater than 1.33. So your process is capable. And then we go for others. CPK also greater than 1.33. So your process is capable. And then we go for this distribution. So your process also in your center or in your target, and then the peak also in your target. So the this process is capable. And okay, the process is capable. Or you can refer others index like ppm. Okay, here. So also okay, because doesn't have anyone outside from this specification limit, whether it's lower or upper specification limit. Okay, so I will do, maybe you using capability, which is CP and CPK, or you can using PP or PPK. If you have a target, so they can calculate CPM for you. If you doesn't have, so CPM doesn't have here. Also, you can go directly to your process, because during the interpreting the result, is it how, if let's say your process is not capable, how to do? So maybe you need to go for reduce the variation, whether you need to shifting to target from left or from to the right. Okay, need to go for the target. For the CP, only focus include in this specification or not. But if you go for target, if you want to know about your process is our target or not, so you need also calculate for the CPK. Okay. So this one is for capability analysis. So we have also others analysis. So go for stat. Go for quality tools, we have another alternative. We choose capability Sixpack. In capability Sixpack, already have assumption. Okay, so you choose normal. For example, here is your diameter, subgroup 5. This one is your lower. This one is just upper, is 74.05. Your histogram. Okay. So I will do, go to stat, go to quality tools, capability Sixpack, choose normal. Okay. So here is your diameter. Okay, here is group subgroup 5. Okay, here is 73.95 for lower, and then your upper spec 0.1. Your target is 0.4. And then you click OK. Okay. So now if you're using Sixpack, we already, if you're using Sixpack, we have kind of this control chart, and then we also for the normality test. So if you're using Sixpack, you can present all the assumption, and then also we have a capability histogram here, and then we also have a capability plot. So that's why we call it Sixpack, because have 6 pictures in one graph. Okay, so depends on your preference. Maybe you want to using capability Sixpack too easy to you show it the assumption, is it fulfill assumption or not, or maybe you no need to show the assumption, but you just focus only capable. Okay. Okay. So from here, we have a normal. So we have a normality, process capability. So already we have this kind of the graph. If you're using spec, quality tools, capability analysis, so you get this kind of the graph. If you're using spec, quality tools, capability spec, you can get this capability spec report. Okay. So we have a second example, which is non-normal data. Okay, quality engineer at a company that manufacture floor tiles investigate customer complaint about wrapping in the tiles. Okay, to ensure production quality, the engineer measure wrapping in 10 tiles each working day for 10 days. Okay, the upper specification limit for the wrapping measure is 6 mm. Okay, so the open worksheet is style. Okay, so I open this. Okay, so tile wrapping, open with Minitab18. Okay, so this way is the tile wrapping. Okay, data set. So is it we need have a 2-step. The first one, we need to find the distribution, and the second step, we go for capability analysis. We assume that this data set already fulfill the first one is in control stage. Okay, so go for the stat, go the quality tools, and then choose individual distribution identification. Okay, so I repeat again, go to Stat, Quality Tools, you choose individual distribution identification. So the first is wrapping, your subgroup size is N. Okay, so is it you just only have a specified distribution? So for example here, I will using all the distribution in the Minitab. We have 60 distribution. So click OK. So they will provide all this kind of the distribution. So we go for the subgroup, okay, session window here, and then you see the p-value. Okay, based on this p-value, okay, we get almost Weibo distribution is almost for this process, okay, because the p-value is more than 0.05. Okay, so now we already know the distribution of this process. So go to Stat, go to Quality Tools, go to Capability Analysis, choose non-normal. Okay. So I will go to Stat, go to Quality Tools, go to Capability Analysis, choose non-normal. So you choose here is wrapping. Okay. So we know now we fit distribution is Weibo distribution, and then your upper specification limit is 6. So your upper specification limit is 6. Okay, and then you click OK. So you get this kind of the capability. Okay, as we know, this one is non-normal data, so Minitab not compute for CP because we just proceed with the PP and PPK. Okay, so I will do again. Go to Stat, go to Quality Tools, go to Capability Analysis. You choose non-normal. Okay, and then here you choose wrapping. So we know the distribution is Weibo, your upper, and then click OK. So you get this kind of the graph. Okay, so based on this PPK is less than 1, so your process is not capable. So if you look back in this histogram, also is the process is outside from this upper specification limit. So also we consider that the process is not capable. Okay, so this one is if you want to get the capability analysis, you using a specific distribution, or we have another alternative. How the same data, okay, the same data. So how we go to Stat, okay, we go for Quality Tools, we choose Sixpack. Either you choose the capability analysis, or you can choose capability Sixpack, and then we choose normal. Okay, we choose normal. So here is your wrapping. Your subgroup size is 10. Your upper is 6. But now we know already the process is not normal, but we want to transform. Okay, we want to transform this process. Okay, so you click transform, and then you choose whether Boskop or Johnson transformation. Okay, so you choose whether Boskop or transformation. For this case, I choose Boskop. Okay, Boskop is more easy to understand rather than Johnson's transformation. Okay, but you can do based on your preference. Okay, so Boskop, click OK, and then click OK. So you get this kind of the capability analysis. So here is your process is capable. Normal is a normal. After you transform the process using the Boskop, and then you get your PPK here also 0.51, and your CPK also below than 1. So your process state is not capable. But now you fulfill that assumption, which is in control and the normal based on the transformation method. Okay, so if you facet with the non-normal data, you can proceed both way. Okay. Either you proceed with the specific distribution to get capability analysis, or you can do the transformation, whether box-cut transformation or Johnson's transformation to get the capability analysis. Okay. Okay. So others agenda today, the last part is I need to show how to using assistant for capability analysis. Okay. So I go for assistant. Okay. I choose capability analysis. Okay. So I using the first data set, which is piston ring diameter. Okay. So go for assistant. For capability analysis. Okay, so here in capability analysis, they ask you, is it data type of your process, is continuous? So we proceed with capability analysis. Okay, so this one is data in one column. Okay, so column here is a diameter. So constant is 5. Your lower 73. Okay, your upper 74. 0.05, and then our target is 74. Okay, so you click OK. So I will do again. Go to assistant, go to capability analysis. Okay, choose capability analysis, and then you insert here is your column. Okay, is your constant, subgroup size, your upper and the lower control limit, and then your target, and then click OK. So you get this graph. Okay, if you use the assistant, we have come up with the 3 graph here. The first one is we call it report card. Report card, which is you can verify your analysis by stability. So they check the number of subgroup, and then the normality, your assumption, and then the amount of your data. And then the second part we also call it is a process performance report, which is they provide you capability histogram. Okay, which is this one. And then we have also a capability statistic. Okay, so we provide the CPCPK, and then more advanced, maybe you want also have a Z bench, okay, to compare with the table. Okay, and then your DPMO. And then we have a third graph, we call it the diagnostic report, which is your assumption. Okay, is process control, just is a normality test. And then here is we call it summary report. So for information, if you're using assistant, we also have this kind of the graph. They provide information how capable is this process. So this one is highly capable. So as we know, CP is 1.66 capable. Okay, and then this one, and then you can drop your comment here. So if you're using kind of assistant, so they provide you for graph of this. Okay, so I think for this side, we already done. Okay. Okay, so for this one, so now I open for Q&A session.
The conference is no longer in listen-only mode.
Okay, so if you have question, you can ask me, or you can type me a question and Q&A session. Okay. But I go further for the box, question box. Okay, what is IMR? Okay, IMR is the individual moving range. This is control chart. When your subgroup on so we use IMR chart. Are you sure you can show the, you cannot, you need to die up maybe for going. Okay, sorry. So other question is, what actually is different between capacity and overall? Okay, for the CP and CPK is quite frequent. We get the questions about the CP. Actually, CP is only within your subgroup. It means every time you take the sample, let's say you take the sample and then you measure the sample in 5 times. So we only get kind of the variation in the capture. But for the CPK is we PP is we calculate between subgroup. Okay? So how to transform data if data to Johnson distribution? Actually, we can do the kind of this one. So you need to show here again. Okay, so for example here, this is step, but you need to choose Johnson if you consider Johnson the best transformation. Okay, so step, go to quality tools, go to maybe you want to choose Sixpack already, normal, and then here is transform, choose Johnson transformation. Okay, so for this, I show it for stock transformation. So now it's Johnson transformation. Okay, and then you click OK. So you get the same graph. Okay. So delete. We get the answer. Okay. So depends on you how to you transform the data. Okay, but basic once using stock because it's easy better than Johnson's transformation. Okay. When do a normality needs to transform? Transformation is capable when your data is not normal. Okay, so if your data is normal, so you can proceed with the capability analysis, where the capability analysis function tools or capabilities is like. Okay, so make sure before you measure the capability, you need to fulfill the assumption, which is if go back for this. So we go back thing. For this kind of assumption, so you need to fulfill this assumption, okay, and it's a reliable value, okay. So I try this step conduct capability. Other questions before we stop this session. So before we start this session, I will hopefully you get some knowledge. Okay. But okay, so if you want to further, you can take our website, or you can follow us at social media pages like Facebook, get more and click to using or enhance achieve you can also drop us question at the or Minitab18 for the question. Any question? Hello, any question? You guys want this material, you can ask your email at the box panel So if you have questions, so
refreshing.
So if doesn't have question, so I think hopefully you guys get some information from this sharing session. So please follow us at Physics System, okay, to get more tips for capability analysis. So hopefully you have a good day and thank you.
你看一下那个100如果很难，你看 operator 可以做嘛，如果 operator 可以做，我们第一个 reward ammo 叫他们 present 嘛。